section 5.1, discrete random variables and probability distributions. So two things we're going to talk about in this section. The first one is, what is a random variable? Let's say we run a survey for students in a class, and we ask them how many of them they like one subject, and how many like two subjects, how many they like three subjects, and so on and so forth. And then we recorded the data in this table. So the number of subjects, let's say in the first column, and then here we have the frequency. The frequency, how many people like it, one subject, 2, 3, and 4. We found out that 12 students said they like one subject only, maybe only math or only bio. 8 people said they like 2 subjects. Some people said 10 here for 3 subjects and 4. A total of 34 students survey. And then relative frequency. Relative frequency, that the way you find, you take the 12 divided by the total, that's 0.36. 8 divided by 34, 0.24. 10 divided by 34, 0.29. And 4 divided by 34, 0.11. And this total frequency here is always 1. So let's say we suppose that we pick one student from the class we surveyed at random. So then the number of subjects is going to be different for every different student we select. And in this case, the number of subjects, as I said, is different and varies from student to student. Varies from students to student. And so it is called a variable. So the number of subjects is called a variable. So we select a student at random. The number of subjects obtained, is called the random variable, because you randomly select one student, and that's a variable, so it's called a random variable. So we introduce a definition here for random variable. Random variable is a quantitative, so it's a number of value, quantitative variable whose value depends on a chance. It depends on chance. Maybe you go survey different class and then you will get different data. You know, maybe more people would say I like only one subject. Maybe less people say I like only one subject, and so on and so forth. So that's what a random variable is. That's what a random variable. And then here, since let me write that down. Since the number of subjects is discrete. Discrete means you can point them out, you can list them on the graph. It's not a continuous one that goes forever. It's discrete variable, then it is specifically called discrete random variable. So now we come to this one. A discrete random variable is a random variable whose possible value can be listed. So as happened here with the subjects that we selected. In particular, a random variable with only finite, that's why it's discrete, finite number of possible values is a discrete random variable. Now notation wise, we use small letter like a small x, small y, small z to represent variables, but capital X, capital Y, for random variables. And in this case, it's going to be the number of subjects. So for example, like when I write x equals 2, capital X equals 2, this number represents the selected student who likes 2 subjects. Now in the probability language, we can write find the probability that the random variable is 2, or in general find the probability that the random variable is small x. That's in a probability language. Now after the talking about variables, random variables, and discrete random variables, we have another thing to introduce here. Is called probability distribution. So probability distribution is basically a listing of possible values and their corresponding probabilities in a discrete random variable. And I'll show an example on this in a minute, but that's what the probability distribution. Now from probability distribution we will be able to construct what we call a probability histogram. So in the probability histograms, in the horizontal axis we list down the possible values of discrete random variables. In this case, like we had the 1, 2, 3, 4, those are the possible discrete random variables. And then on the vertical axis we list their corresponding probabilities. This is an example of a probability distribution variable. They talk about, let's say, the number of siblings. That's just another survey, and they ran another survey and they found that there's about 0.2, that's 20%. If you want to convert, multiply by 100, 20% of the people surveyed, they said that they have no siblings. About 42.5% of the people surveyed, they said they have one sibling. 27.5% of the people surveyed, they said they have 2 siblings. 7.5% of the people surveyed, they have 3 siblings. 2.5% of the people surveyed, they have 4 siblings. So now one thing important to know here in the probability distribution, that the sum of all the probabilities, it must add up to 1. It must add up to 1. So we can add a note here. We can add a note. If you notice, when I run it here, I run it as a relative frequency, relative frequency, and notice how the total adds up to 1. Same thing here with the probability distribution. The total adds up to 1. So we can write a note that the relative frequency distribution is to a variable as a probability distribution to random variable. I'm going to write RV random variable. So in the table for the frequency we did, it was just a variable. Here we're talking about random variable. And now on the right side, here we put down whatever we have on the x goes in the horizontal axis, 0, 1, 2, 3, 4. And then the first one went up by, they went up by 5%, 5, 10, 15, 20, all the way to 45. And then the first axis was 20%, so it went all the way up to 20%. Next one was 45, and so on and so forth. So this is called a probability histogram. And we're going to use it later on, see why we need to learn about this in the later sections. So another note here that we have it ready is in any probability discrete random variable x, we always have the sum of all the probabilities. They have to add up to 1 as it happened in that table, and it must add up to 1 all the time. So now let's take a look at another example. Let's say we have the random variable x with a frequency, say 5, 7, 8, frequency 25, 40, and 60. So suppose a member is selected. Suppose a member is selected at random. okay, we can construct the table here for the probability distribution. So x was 5, 7, and 8. So the probability for the random variable x equals x is what? Here a total, if you add them, the total is 60, 40, that's 100, 125. That's the total. So what do? We take the 25 divided by the total to get the probability, which is 0.2. Take 40 divided by 125. That's 0.32. Take 60 divided by 125 is 0.48. So note, let's say they ask us to find the probability that x is 7. What is that going to be? Well, we just found it. This is 0.32, right? Note, again, as I said before, if you add these 0.2, the probability is 0.32, 0.48, that gives us 1. And probability distribution always has to add up to 1. So what about if they ask us to find, for the same example, the probability that the random variable, discrete random variable x, is at least 7? So this means, in other words, you can write the probability that capital X is bigger than or equal to 7. So bigger than or equal to 7, in the table A, only have 7 and 8. So that's going to be the probability X is 7 plus the probability X is 8. Because it's going to be 7 or 8. Or means addition. And for the first one was 0.32 from the table, and the second one 0.48. If we add them up, we get 0.80. And we can construct a histogram or probability histogram for this. Maybe if you like to graph it, we had 5, 7, 7, 8, and then it depends on the numbers you have. Maybe you want to go up by 0.10, 0.20, 0.30, and then from there just construct the bars. The first one was 0.20, so just construct a bar here up to 20. And then make sure the second bar will touch the first bar. Next one was 0.32, so a little bit above the number we just got. And the last one was 0.48, so 40, 50, say like that. Okay, so the next thing is, let's say they ask us, suppose that A and B, capital and capital B, are random variables. If the probability of A bigger than 3.24 is 0.06, and the probability of B, actually before B, probability of A that this is going to be less than is also 0.06. We need to find the probability that A is exactly from -2.4 to exactly 3.24. Now, how do we do that? Well, think about this. You're talking about this event or random variable, so random variable A. So the total number corresponding to this random variable, the sum of all of the probabilities should add up to 1. So you are talking about something above 3.24 if you put a number line, and below this. So this one here is 0.06, and this is 0.06. And they ask us what's in between. Well, the way you do this is that is the probability that the random variable A, or we can, before you do this, you can say the probability it's the random variable less than -3.24 plus the probability that A is between -3.24 to exactly 3.24 plus the probability that A is above 3.24. All these must add up to 1. They must add up to 1. So the first one is 0.06, and we are interested to find the second one. Plus this one here also given 0.06 equals 1. And then what we need to do from there is we combine these together 0.12 plus the probability of negative 2.4 A 3.24 equals to 1. Then we just subtract 0.12 from this. So it's 1 minus 0.12. And that would give us 0.88. So in general, let's say, just a random example, if we are asked to find the probability that a random variable x between 2 and 4, one thing you can do for a discrete random variable, this would equal the probability that x is 2 plus the probability x is 3 plus the probability x is 4. And these would be usually given to us, and it would be easy just to substitute and solve for that. You can read through the interpretation here and then the histogram interpretation. It's just if you talk about it proportion wise or probability wise, it's the same thing. The numbers are exactly the same. The numbers on the x-axis are the same, and you get exactly the same histogram. So in summary, here is just an introduction to what a random variable is. We talk about what is a variable. We use those small x's for variables and capital X for the random variable, because you are randomly selecting one of those people in the survey to either run a study or find a probability or something else. And then we introduce, because the random variable here that we're talking about has to do with the finite number of values we're picking, so then specifically we call discrete random variable. Then we looked at what a probability distribution is and how do we find or construct a probability histogram that corresponds to that probability distribution. So every variable has its corresponding, as you can see in the table on the left, has its corresponding probability. All these probabilities, they must add up to 1.